Okay, we're going to have a panel discussion now, and I've been asked to put together some questions for the panel as it relates to what we heard today and other topics that I thought might be interesting to discuss. You've met Dan here on the stage and Ben on the stage. Person directly to my left here is Steve Miller. Steve's my academic nephew. I was an external examiner on his PhD, so if I start to grill him up here, it's just an old habit. Steve joined you 2 months ago, I guess it is now, right? So really take the opportunity to meet with him. He's a research geneticist in your organization and very, very qualified, and we're really glad to have him back. He started off at the University of Guelph, spent some time in New Zealand. I told him he'd come back, he did. He got tired of an ocean body around him, so he came to St. Joe's, Missouri. So welcome back to the States, Steve. Let's start off with some impressions. Dan and Steve, I'd like to ask you guys first of the kinds of information we heard in Juan's talk about futuristic looks at DNA concerns and things like that. What was something that you took away from that, Dan?
Well, John, one of the things that I took away from it is just how fast this technology is changing, and I know from where I sit and I see the speed of it, I know that it has to be overwhelming for some of our members and your commercial customers down the road to just see how fast this does come along, and so it's a challenge for us to stay engaged and to see what's happening throughout the science community, and that's really our responsibility to stay engaged with the scientific community and to help sort through the technologies to see what's going to give Angus breeders the most benefit.
So you've talked about your strategic plan, and you've got a rapidly changing technology. How do you approach that kind of subject in a strategic plan?
Well, I think the one thing that when you think about genetic technology, you don't make a plan that's too long a plan, because we know that if you think about where this technology was 3 years ago, that if you'd have told me that we would process 110,000 genotypes on registered Angus cattle to go into the evaluation, I couldn't even fathom that. And so that's just quickly how things are coming along. But I think we have to remember that these technologies are opportunities. They face challenges, but that as it's been with a lot of other technologies, whether it's artificial insemination or ultrasound measurement of carcass traits, as Angus being an early adopter really positioned us for success down the road. And so we can't be too afraid of those and have to look for the opportunities and see how to help ourselves stay ahead.
Steve, what'd you take away?
I guess when I listened to Dr. Enriquez's talk, I thought about change and how fast things change. And I reflect back to December 6, 1996, when you were my external examiner. And I thought, well, some things change and some things don't, because I'm still putting on a tie and my jacket, and I'm still getting questions from Dr. John Pollock. But my thesis at the time was multi-breed genetic evaluation of beef cattle, which was really important at the time, and it still is today. But there wasn't anything about DNA in that thesis. There wasn't a drop of blood or a genotype. It wasn't even really thought about. And the chair of that defense committee pulled me aside afterwards, said, good job today, Steve, and everything. You realize in the future that you'll be analyzing the DNA of these animals, and you'll actually be able to genotype an embryo and determine its genetic merit, and you'll be able to just speed up genetic progress. And it kind of set me back a little bit, but we're here today. That's 20 years ago. So I think I come away from Dr. Enriquez's talk this morning is, don't say no. Don't hear about technology and say, no, we're never going to do that, or no, that's too disruptive, we're not going to engage in that. We have to be open to new technology.
Ben, what are you telling producers back there? Now you've moved north up into real cattle country there in Australia. What are you telling producers there in terms of what to think about next? What's the next big thing you think is coming in Australia?
So in northern Australia, we have lots of challenges. We have heat stress, we have parasite challenges, we have many different breeds as well, and we also have a lot of indicus cattle. And one of our big challenges at the moment is to make our genomic evaluations work across multiple breeds and the two subspecies, indicus and taurus, for traits like parasite resistance. And the only way I think we can really make those genomic evaluations work really effectively is to go beyond what we have at the moment, which is the 50K SNP chips on which most of the genomic evaluations are based, to whole genome sequence data. So rather than just have these snapshots through the genome that we hope are tracing the mutations affecting the traits, we really have to start thinking about zooming in or nailing the mutations that are really causing the differences in our animals. So you heard a little bit this morning about whole genome sequence data, these 3 billion ACTs and Gs. That's where we're moving next to try and increase the accuracy of our multi-breed evaluations.
So you've talked a little bit about some novel traits, relative in definition being traits that we don't routinely collect data for in genetic evaluation. Dan, over to you. Where's the Angus position and future looking like for these novel traits?
Yeah, John, that we have some data that we're already collecting and have some data collection strategies in place for some of these traits. Some of these, many producers here in the room have been submitting foot scores to us, for example, and we are working toward a prototype genetic evaluation using that data to try to give people a better genetic predictor of long-term structural soundness. You and I worked together many years ago on the Carcass Merit project that collected tenderness data, and we hope to soon release a tenderness EPD. It's difficult to get new data for that particular trait, but we are getting some through collaboration with research universities. So that's another example of something that we hope to put in Angus breeders' hands in the near future so they can decide if that's something that they want to incorporate in their selection programs. And then long term, we're thinking about some of the regional adaptability things that Ben mentioned, that heat stress and those sort of things aren't unique to Australia, obviously, that there's parts of our members' operations that face the similar challenges. And so I think that over time we're going to be looking at more of those regional things, fescue tolerance, altitude disease, all those sort of things, so that we can ultimately give our members the tools to really tailor the genetics to best serve their customers.
I'll come back to that in a minute because that G by E is an interesting area. Steve, research in novel traits, what do you think is down the road for the beef industry in general, if not Angus alone?
Yeah, something that Angus is engaged in is they're calling a structured SAR evaluation. Getting more commercial data. So the primary emphasis is carcass traits, but I think there's lots of other commercial traits that we have to focus on. Health is one of them. Feedlot health. What are better phenotypes we can get on the health side, and then basically train genomic predictions for those traits. I think that's really important.
So you both mentioned genetic evaluation as the end product of collecting that data. The other alternative we've often heard about is create discovery populations, get a genomic test from that, and move forward. What's your thoughts on that direction versus trying to get it into an evaluation system?
Well, I think that John, we realize that some of the traits that we're talking about, not every member will be able to routinely measure on farm, but I think that a lot of them we want to continue to update phenotypes and any opportunity we can, and that's true for all traits. That's not just for some of these novel things, but certainly the ultrasound data, those sort of things. We know that with the genetic evaluation, if we don't continue to collect current phenotypes related to the newest generation of animals, that there's some decay over time in terms of the accuracy of those predictions. So I don't think we'll ever be satisfied with developing a prediction based on one population without trying to at least try to continue to get more phenotypic data to tie to that and to enhance the accuracy of it. But we realize that for some of these traits, that it will be a little more challenging to collect, and hopefully we develop partnerships throughout the industry to collect that data and bring it into the Angus database.
Ben, where are you going in Australia on that?
Well, the genomics opens up a whole new raft of possibilities. And one experiment we've talked about is going into every restaurant in Brisbane where I live, and wherever somebody's eating steak, just take a little chunk of that steak and then ask the customer, how do they rate the steak? Do they think it's a great steak, poor steak, or whatever? Do that for 100,000 steaks, get the genotype of each of those steaks, and then just come up with a genomic breeding value for consumer acceptability directly, straight out of that data.
So if you did multiple steaks in a restaurant, the contemporary group is the chef.
Correct. But this is actually what the human geneticists do. They allow a bit of deterioration in data quality like contemporary groups by just doing enormous numbers, by doing millions of people for disease and so on. And don't get me wrong, I love really good data, but for some traits we may have to go to this pure genomic approach.
So we talked a lot about genomics in the seed stock industry, and the application in genomically enhanced EPDs is really evolving. What's the view of getting genomics into your customers, the commercial operations? How's that working here in the association and the industry in general?
Yeah, that we're seeing commercial producers that have had a positive experience buying a genomically tested bull, and they see the improvement in accuracy and the reduction in risk from buying a bull like that, and that their expectations are met or exceeded at a higher rate than what they were previously with that technology coming along. And then they've asked about how they can apply that to their heifer selection strategies and those sort of things. We know that there's not as much opportunity to change a population through female selection as there is with sire selection, but even still, that we're now seeing those tests come to the commercial marketplace at a reasonable price so that they can make selection decisions on their replacement females. And putting that technology along with their sire selection, we're seeing folks make even more rapid improvement in the economic efficiency of their operations.
Steve?
I think something that's, when we think about how we market cattle in terms of commercial calves, we sell calves in groups. And, we for a buyer of a group of calves to have predictability on that group, genetic merit for carcass traits, feedlot profitability, carcass profitability, ability to hit CAB, for example. Cheaply, there's some new efforts around the world basically working with, actually, a lot of it comes from Australia, and that is working with pooled genotypes. So if you think about a group of calves and pooling the DNA on that group of calves and a genotype that could give a genomic profile for the group cheaply, I think could change the way genetic information flows through the supply chain, but that could drive further value for genetics on bulls. So it really kind of could better tie, I think, the industry together in that genetic seed stock pipeline from the breeders right through to CAB for that matter.
Ben, you're working now with some very, very large operations up there in northern Australia. What's their view on this?
So they're using the technology in multiple ways. These are organisations, pastoral companies, that have up to 500,000 cattle within their enterprises. And the other great thing about those companies is they're vertically integrated. So they capture the full value of genetics because they own the feedlot, and in some cases they own the processing plant as well. We're talking about doing a few things with those companies. One is just using genomic breeding values to accelerate genetic gain in their bull breeding units. The other exciting possibility there, though, is they do use multiple breeds because they're typically in these regions that have heat stress, have reasonable parasite loads, but at the same time they want to chase meat quality and good fertility. What they have to do is stack the best bits out of each breed together to get the animal that does all those things. And one exciting project we're just starting on is to do exactly that. Use the genomic information to identify which chunks of DNA convey the best meat quality, convey the best fertility, the best parasite resistance, regardless of breed, and then try and come up with a breeding program that stacks all those bits of DNA into the one animal, into a composite animal that has good meat quality and can survive in those harsh environments. And that's a pretty exciting use of the technology, I think.
I feel like Jack Trapper or Bill O'Reilly, pick your station. I've never done this before. This is fun. I wish my contestants here were a little more argumentative. Let's go down a step from the commercial person to the feedlot. What's happening in that arena relative to connecting it to your genomic and genetic program?
Yeah, John, that's a good point. That we see that we've been able to capture a tremendous amount of data from our members, the seed stock producers, and submit that. But there is throughout, one of the frustrations for me when I view the beef industry is the loss of information as ownership changes. And it seems that with the technology we have today with electronic ID and instrument grading and all those sort of things, that there ought to be a way to connect that supply chain more closely. And that's something we're going to be spending some effort toward in the future, is try to do an even better job with the commercial program to share information through the segments. We know there are a lot of AI-sired, Angus-sired calves going through processing plants every day that would generate reams of data that would help us bring back into the genetic evaluation and add accuracy to our predictions, add accuracy to our genomic testing, those sort of things. But it's no small challenge to capture that identity and bring it back to where we need it in the office and put it into work for you folks. And so that's something that we're going to try to build more of those connections and relationships with the feeding segment, with the packing segment, to try to share that data more openly, because ultimately we all benefit if we can make more rapid genetic improvement.
That information goes in both directions. You get the data coming back and the genetic information going forward, because in many cases you may know the sires of those calves, if not the individual calf themselves, but as a conglomerate. Steve, what research do you look to the future for here in the association that relates to the feedlot, connecting it back to these seed stock programs?
Maybe just further on Dan's point about information. I think Ben's project, with the stakes, you sacrifice some data quality for volume, and I think that's how we need to tie in feedlots and packers. You think about the problem of getting phenotypes. I see in a way feedlots and the packing sector should be a boon really for the seed stock industry, because instead of, like, say for now with carcass traits, we need ultrasound technicians run around all these seed stock herds all over the country. In a packing plant, all the cattle come to one spot. There's someone's already paying all the trucking to bring them all in there. So really, we can sit in one spot and get a lot of phenotypes. And you think about, well, what kind of massive phenotypes could we get at packing plants on a health basis? Well, there's quite a few. There's lung lesion scores is related to things like pneumonia and bovine respiratory disease. We've got abscesses on livers. Those things are fairly straightforward to collect. There was a project in New Zealand looking at lung lesion scores in lambs, and it's a fairly heritable trait, like 18% heritable for a health trait is quite high. So when genotyping first came along, we thought, well, this is great. We can just go to a packing plant and we'll just get all this data. And actually, as Mike Goddard from Australia pointed out, he said, that's a really good idea, Steve, but the problem is it's just still too expensive. It was $100 a pop at that time. But as the genotyping costs come down, it actually makes it realistic to get into these high volume, lower quality data scenarios and actually get that information to feed back up for breeding values.
In your vertically integrated programs, what are they looking at in the feedlot?
Well, some of that's already actually happening. And bovine respiratory disease is a big one, but just potential to marble and profitability of the animals entering the feedlot is important, I think. Just to pick up on that information, if you can pull that off and have the genomic information connected to the packing plant information and so on, what you could do for the producers, commercial enterprises, is offer them a benchmarking service. So you could go into their herds, genotype a sample of animals, and then say your genetic level for these important traits is about here. And if you use the top size in the Angus breed or moderate size in the Angus breed, you can quickly lift up the merit of your herd to this point. So I think there's real potential to use it as a benchmarking tool and to let people know where their current genetic merit is and how quickly they could move the herd.
If you think about the consumer as another step in this process, we've always thought about the consumer in terms of the quality of the product and attributes like that, but the consumer's interest in our industry is expanding. into well-being and aspects like that, which brings in measures of stress and other attributes like disease. What's your thoughts on addressing those issues? I think we do a good job on the consumer side, as you saw with £1 billion, of enticing them to buy our product, but how does that work?
Well, I think we can't ever take the consumer's desires for granted as well, that their preferences are going to be changing over time, and there's certainly different segments that some we're meeting very, very well, and some we maybe not as well as we could. And I think there is the opportunity to tailor genetics to specific consumers. John, you've talked in the past about some efforts with healthfulness of beef and targeting amino acid profiles and some of that sort of thing. Maybe you'd like to share a little bit more about some experience along those lines and what you think about the opportunities there?
Yeah, we actually did a very large project at Iowa State in collecting Angus steaks, actually, looking at the amino acid profile and iron content, actually. And there's quite a bit of variation in the iron content. And you do have target audiences for iron. Young women are an excellent example of that, where that profile would be useful. It got back to how do you get to that point and how do you pay back the testing for that. But there are a lot of opportunities to do that. Paul Janot, many of you know, always likes to make bold predictions because he tells me he forgets right after he makes them, so he never has to come back and worry about them. But he said half our meat is going to go to China in a few years. Stuart, I forget how many years that was. There's a whole different consumer. How are you preparing for your product on a global scale, since you're currently doing more than that, more of that than many other locations or many other breeds?
And it's a little more complicated than that as well, because China is an enormous country, and there are different preferences for different types of beef within China as well. It's just an additional complication.
So in your strategic planning, do you have China as a high-profile target?
We're definitely, the CAB folks can tell you about, the growing international markets and the opportunities that we've had. And, I think that brand obviously has great recognition all over the globe. And, but we are definitely thinking about those export markets, and as they arise, opportunities for the beef industry to try to be early in the market and meet those consumers' needs and expand the impact of Angus genetics all over the world.
Stuart mentioned the F250, this new variant panel that has come out of much of the research that was done in these 3 large grants. The F250 has on it mutations that we believe have an impact on the characteristic directly, not as a marker. Where are you on looking at that particular panel, because a lot of Angus cattle have been done with that?
Yeah, so we've some of the collaboration we've had with universities is that chip to, there are some theoretical markers that may have a larger effect than the things that we're currently testing for. We need those in those research populations combined with very extensive data collection, but we have good partnerships to receive that information and also discussions about genotyping strategic sires to benefit the findings. Really, I think what I see then in that F250 are some of the, some of those markers may turn out not to be as valuable as originally proposed, but some of them may be on the next version of the chips that our members here in the room will be purchasing to test their cattle in the future.
Do you think that particular panel will have value on a within breed program? We did some initial investigation in that, and the 50K panel does a reasonably good job of capturing the variation that's recognized there. But perhaps moving outside of a breed into crossbred animals may be a place where that has value. Steve?
Maybe just a comment about the 50K. I agree with you, John. I don't think maybe even 5 years ago people would have predicted how well the 50K has worked within a breed. And because we thought at that time when we go to these higher and higher densities, it'll just get better and better. But we've actually found the 50K really does a great job within Angus. So at the moment, Angus is sitting at, I think I checked yesterday, 272,000 genotypes or something. I I think there's a lot we can do more with the data we have with those 50K, and we've got these potential causative mutations, say on the F250, but even within Angus data, now that we have this massive amount of genotypes, we can start looking at what we call haplotypes. So, those significant genes exist within a haplotype in Angus, and we can start just actually better using, I think, the genotypes we do have to identify, what are the haplotypes that are contributing to those traits. And like Dan said, the technology keeps changing, the genotyping technology keeps changing. The chips, I think, as breeders, you probably said, well, it just seems to be a moving feast as we've gone along. Well, probably get used to it, because I think you'll probably see, chips will just continue to come out different in the future and more rapid, and it'll give us the ability to put new content on and keep making it better.
Ben, is that where you're going with your sequence data?
So the sequence data, we're looking very heavily into that and starting to use that data to do the multi-breed predictions. But I think even within breed, there's a good use for the sequence data and the F250 as well. And that is when you're running a very aggressive genomic-based breeding program. So you're selecting animals on their genomic breeding value and breeding from them as early as possible, and using a lot of ET or even IVF programs as well, in vitro fertilization. And there you can have a situation where you breed for multiple generations using the genomic information, but you don't get back phenotypes on the original animal that you started breeding from until you've gone a few generations into the future. And what we've seen is with the 50K, this is in dairy cattle, if you go for too many generations without getting phenotype data back, the accuracy of the genomics starts to decay away. It starts to drop off because the SNP or the marker that's tracking the mutation, that association starts to break down. So the sequence data, or maybe the F250, can overcome that for you, because the association just holds up generation after generation. So if anybody in this room is contemplating running a very aggressive genomics-based breeding program, and this is happening in a very large scale in dairy, then going to a higher density and even sequence may be worthwhile.
We heard a little bit about changing genes, gene editing. What's the view of that from a breed association point of view?
John, that's one of those technologies that we're hearing more about all the time. I was on a panel in North Carolina about a month and a half ago with some folks from a company called Recombinase that are very aggressively working. Right now, their primary focus is polled Holsteins, because they see that as the biggest market opportunity from an animal welfare standpoint to create Holstein cattle that don't have to be dehorned. Not only is that an animal welfare improvement, that's also a efficiency improvement for the dairy farm as well. Now, obviously, that's not anything we have to worry about, but the next thing that they're talking about is slick hair coat, and to be able to make a very simple edit to take any beef or dairy animal, change nothing about it except the fact that this animal wouldn't be more like a centipole, slick hair, more like what you'd see in some of the African breeds and some of those sort of things. And so, that's something that we're going to have to confront as an organization, and how we feel about that. It's a technology that, maybe wouldn't be as much of a big deal in Indiana, but there's certainly parts of South Texas and the Gulf Coast, and then certainly think internationally about the benefit to that, the production efficiency that could be gained there. And so that's something we're going to have to wrestle with a little bit from a policy standpoint. But again, I think we'll come out with something that ultimately will be a benefit to our members in the beef industry.
I mentioned to you earlier, a friend of mine said, create me a white Angus for down south. Steve?
Can I just comment on that? I want to point out something, that Australian cattle breeders actually did this 100 years ago. There's a breed called Murray Grey,
Yep.
which is a silver Angus, essentially, very good meat quality and so on. So if you want white Angus, just come to Australia.
Okay, well, that's my questions, and let's give the panel a round of applause, and thank you very much.